Hello, True Health Seeker, and welcome to another exciting episode of the Learn True Health podcast. Today we have with us an amazing naturopathic physician who is going to dive into this really complex topic and help break it down, this understanding of epigenetics and gene methylation. Dr. Kara Fitzgerald has such a plethora of experience that she brings to the table. I'm really excited for you to hear today's interview. But first, before the interview, I want to thank you so much for being a listener to Learn True Health podcast, and thank you so much for sharing this podcast with those you love. I get daily emails from you guys, and I love hearing from you. If you ever feel like writing me, go ahead and write me, ashley@learntruehealth.com. I would love to hear from you. If you have any questions or feedback or comments, please feel free to email me. Now, if this show has made a huge difference in your life and it's touched you and it's helped you to start to learn how to have better health, and you're even starting to see results, which I get lots of emails all the time from listeners saying that all the things that they've learned on this show and that they've implemented have greatly helped their life and helped to improve their health. And if that's you, please consider being a Patreon supporter of the Learn True Health podcast. You could donate $1 a month, $5 a month, whatever you feel moved to contribute. It helps to mitigate the expenses of putting on the show, and that really helps me a great deal. And I truly appreciate your support. You get some perks from being a Patreon supporter. You get to listen to episodes commercial free, and I usually upload them before I upload them anywhere else, so you get first crack at all the episodes. I'll also mention your name on the show, and thank you so much for being a supporter. And of course, if you were to join at the $25 a month level, I send you a book every time we do a book for the book club, and we read the book together, and we get on Zoom and have video conference calls together. So if that sounds interesting to you and you'd want to join the book club, you'll definitely want to join soon, because we're going to be starting up our next book that I'll be mailing everyone shortly. We have 3 new Patreon supporters for the Learn True Health podcast in the month of July, so I must thank you guys. Thank you, Joy Rosen, Bonnie Kretchik, and Mary Prezi. I hope I pronounced your name. I am such a fan of you guys for joining us in Learn True Health mission to support this podcast and get all this great information out to as many people as possible. Because of the Patreon support that I've received from you guys over the last few months, we actually just purchased a soundboard that we'll be installing to make even better quality audio for all of you. So all the listeners can thank those who have been contributing each month to the Learn True Health podcast. And also, we have begun to advertise. There's an affordable way to advertise on digital billboards. So we're testing that out to see if that is making a difference. And I just can't thank you enough for all of your support. So thank you for sharing it with your friends and family. And thank you so much for being a Patreon supporter. I also appreciate it when you go to iTunes and leave a 5-star rating and review. I read every single one of them, and just like I read every single one of your emails, I feel very touched that you reach out to me and that you give the positive feedback. Also, if you want to join our community in a different way, you can come to Facebook and just type in Learn True Health in Facebook. And from there, you can join our free group for all the Learn True Health listeners. We have great conversations, and I'd love to see you there. Excellent. Well, enjoy today's interview. Welcome to the Learn True Health podcast. I'm your host, Ashley James. This is episode 274. I am very excited to have our guest with us today. Dr. Kara Fitzgerald is an amazing naturopathic physician, and today we're going to dive into one of the most fascinating topics, methylation and epigenetics, and this understanding that through nutrifying the body, we can change the expression of what our genes are doing to repair and help heal our body. And also, there's the opposite side of the coin. What kind of diet and lifestyle things are we doing to harm our body? So how did you get into this subject, Dr. Fitzgerald? This is something that is a very niche and very new subject. I only started hearing about epigenetics maybe about 5 years ago, so it's pretty new, I would say. How did you, as a doctor, want to get into this?
I did my training after I finished medical school. I did a postdoctorate position in nutritional biochemistry at a lab, at a clinical laboratory that was very forward thinking. So we were analyzing what they call kind of omics, looking at organic acids and amino acids and fatty acids and toxins and all sorts of stuff um, before the advent of the current systems medicine model. I'm sorry if I get too complicated in anything, Ashley, just have me flesh out the information. So basically we were looking at evidence of how genes were functioning in our bodies by looking at the amino acids and the various things that were products of gene activation. So we were getting a snapshot into what was happening sort of metabolically under the hood in an individual, how
Mm-hmm.
enzymes were functioning, how nutrients were behaving, whether toxins were influencing. I mean, just a lot of really, really cool and fascinating stuff. And at that time, I had a pretty tight think tank that I worked with. The other clinicians and scientists in the lab, we worked closely together and kept each other current. And we eventually started analyzing the microbiome, using PCR, so using DNA analysis of the microbiome, and we were the first lab to do it, to offer it clinically, to make it available to clinicians. So we were pretty early adapters there, but at that time, I just fell in love with this whole field of omics. And um, flash forward a few years, it became routine to analyze single nucleotide polymorphisms, and the whole idea of methylation became really, really popular. Back in the lab, we were looking at evidence of methylation behavior in the body, but it became um, really kind of this big, sexy topic. A lot of patients were coming to me with their 23andMe data. There are many, many websites online talking about if you have an MTHFR mutation, what you need to do, if you've got, all of these single nucleotide polymorphisms involved in methylation and beyond. What kind of supplements you should take, and fairly complex stuff, and sometimes really onerous protocols. But we were all sort of dancing in this new expanded pond of data, of looking at genetic information and you know more um, more than we had access to previously, and it was really exciting. But my background in the lab just keeps me rooted in research, and so some years ago I came in contact with epigenetic methylation. In fact, that same, people who are familiar with methylation, um, that same carbon and three hydrogens that S-adenosylmethionine makes in the methylation cycle is also used in DNA methyltransferase enzymes to mark the DNA, to put these methyl groups all over the DNA. There's many of them, and they're very much involved in whether a gene is turned on or a gene is suppressed and turned off. So DNA methylation is a fundamental epigenetic piece. And extremely important is that hypermethylation of a gene generally turns it off, and hypomethylation of a gene generally allows it to be expressed. Now, if you look more, if you drill down into that further, you'll see that what they call differential methylation patterns of the epigenome, so something hypermethylated or hypomethylated, can have a profound influence on health, or the expression of disease. So, for instance, really important tumor suppressor genes, so those genes that go around and inhibit the presence of cancer, can be hypermethylated and turned off. We see hypermethylation actually playing a role, hypermethylation of the epigenome playing a role in many conditions, and cancer is the best researched. And conversely, hypomethylation will allow a gene to be expressed, and you can see hypomethylation patterns in cancer and other chronic diseases. So, an oncogene, a gene that's going to promote the development of cancer, could be hypomethylated and therefore turned on. And so, somebody who was looking at methylation in my patients and using folate and B12 and betaine and all the myriad interventions that we might give our patients in wanting to support healthy methylation, I was really, as I dove into this literature, I was brought to a standstill. Could we be pushing methylation too far and perhaps influencing negatively epigenetic methylation? And that, um, when I really, really wrapped my head around it um, some years ago, it it just brought me to pause. I mean, we're always thinking about in functional medicine, we just want to deliver the best care for our patients. And, we're early adopters and we're paying attention to the science and we are, very adherent to the precept first do no harm. Um, and so within all of that, we want to pay attention to what's coming down the scientific pike and think about it being applicable. And likewise, are we doing something that we need to nuance more or that we need to change? And the world of epigenetic methylation was a huge aha moment for me that ultimately changed the way that I think and practice medicine. Now, you probably have a few questions.
Oh, just a few. I mean, I could talk about this topic all day. I'm very curious, as I know my listeners are. For example, a few years ago, Angelina Jolie decided to have her breasts removed as preventive medicine.
Let me give you a little background. It's not an oncogene that Angelina Jolie has. She has a defective tumor suppressor gene. So the BRCA mutation that she has is when it's functioning is a robust and incredibly important tumor suppressor gene. A functioning BRCA protein or BRCA gene is extremely important in the prevention of cancer. And we can see from the data that a genetic mutation in that BRCA protein is associated with, a meteoric rise in the development of certain hormone-sensitive cancers. I mean, it's huge. So absolutely didn't roll my eyes. I mean, I've got
Really?
patients with the BRCA mutation, and their family history, they're riddled with very early onset, sometimes uh, life-taking cancers from this particular mutation. Yeah. So, what I would say to you though about that, so she didn't have an oncogene. It wasn't something that promoted cancer. She had a defect in a tumor suppressor gene. So that's super, super important. But we do know we know about some of the things that this massive a functioning BRCA protein does a whole handful of things. And one of them that really interested me, this is a little bit of a tangential topic, but it interested me, and I actually blogged about it on my website. If people are interested, they can take a look at it. So you would just go to my website, drkarafitzgerald.com, and in the search, just type in BRCA, and this blog will come up. Or I can give you a link to it and you can put it in your show notes. But what we know is that this mutation, which is so closely associated with the development of cancer, and one needs to be very mindful around it, also has an increasing incidence. So when they look retrospectively at the associated incidence of cancer years ago, going back to the 40s, they'll see that it was much less than it is today. And
Mm-hmm.
that's not due to the gene, that's due to environmental factors. So the gene is a problem. Having a mutated BRCA gene is a problem, but we also know environmental factors play a role in it. And so that's what you're alluding to, Ashley, that there are in women or who have this mutation, while they may need to think about some of these radical procedures, like she lost her mom extremely early
Mm-hmm.
on, um, there are many environmental things that we can do. And so one of the interesting things about a BRCA protein, a functioning BRCA protein, is that it helps regulate how estrogen is produced and expressed in the body. And there are many natural interventions we can do to control estrogen's behavior and blunt the effect and help it be metabolized as healthy as possible. And so it's a little bit more involved, and I would, as a physician, I would not recommend somebody take that journey on themselves. I would, work with somebody who's competent to help measure what's going on with estrogen and the other hormones and make sure they're optimized. And, you can do all sorts of helpful detox protocols and so forth. So that would be one of the things I would do with the BRCA mutation, but it wouldn't necessarily, it wouldn't supplant considering some of those more drastic procedures.
Got it. And so a BRCA gene is the mutated. What do you think mutates these genes, or with onco, which you're saying is
It's
different?
inherited.
So she's
Yeah.
inherited a mutated gene.
hmm
With onco, is that turned on and off based on, let's say, toxicity, environmental pollution?
Well, certainly, yeah, potentially, yes, and even, in the tumor itself, tumors are able to, alter methylation patterns of the epigenome, to their nefarious ends because they want to proliferate. So, yes, and that is a piece of what we've been thinking about. So, you want to have balanced methylation of the epigenome. You don't want to, it's like the Goldilocks's porridge. You don't want it too hot or too cold. You want it just right. And you also want to allow the body wisdom to make the decision points on how our epigenome is methylated. Like, we don't really understand enough of it to get in there and manipulate it. I mean, there are methylating or demethylating drugs that are used in cancer therapy, and they sort of do, they do widespread demethylation of the epigenome, and while they're helpful, they're sort of not specific. But it looks like nutrients can be a little bit more specific around allowing balanced methylation expression in the epigenome. And let me throw in one more thing. I know this is a little bit complicated, but so I want to say that I no longer just prescribe high dose methyl donors like high dose B12 and folate and some of the other ones with impunity. I pay attention a little bit more and move and use diet and use the myriad other ways we can help optimize methylation expression or epigenetic expression in the body, because there's so much more we can do. So the research on epigenetics really prompted me to pause, not just push methylation forward because we see a genetic mutation in somebody, but to really think about nuancing it in a much more sort of upstream diet and lifestyle based way.
Now, I know a lot of practitioners who, when they uh, do the genetic testing, especially MTHFR seems to be one of the most common ones. So people know whether they're, what percentage are they methylating their B vitamins, for example, right? But there's a lot of other ones that the body has and that have to deal with detoxification, whether the body can, detoxify healthfully or not. And then, of course, if they're exposed to environmental pollution and they're not detoxifying healthfully, that's sort of a 1-2 punch. And then these practitioners are throwing sort of big doses of methylated vitamins at the person. And what you're saying is that you're seeing better results by helping the person fine tune their diet so that you can come back into balance and not do too much methylation or too little methylation. Is that what you're saying?
Yeah, we just want to be mindful around the fact that pushing methylation reactions forward is not always it will likely not as the research progresses, just pushing methylation forward with high dose B vitamins will probably prove to not be the best way. Um, It is, I think, in the short term, if you've got somebody who's got a profound B12 or folate deficiency and they've got anemia because of it, or they've got a really elevated homocysteine, I mean, there's a time and a place where B vitamins are absolutely important. And we need to do them in high dose, or sometimes we'll do them as, little injections. I mean, there's an absolute time and a place for it. But someone who decides that they have a selection of single nucleotide polymorphisms, and therefore they're required to take high dose B vitamins for life, I would, I would, um, I would say that that might not be the answer,
What
and
would
that we
happen
might
if they
want to.
did? Like what symptoms
Well,
would they experience if they were taking too much methylated B vitamins?
so what I would say about that, I know that there are people who talk about symptoms being associated with too much. I mean, a subpopulation of people might get some anxiety, or, um, might have a imbalance in neurotransmitters that could change mood and that kind of thing. But what I'm talking about, Ashley, is, are we methylating genes we don't want to methylate? Are
Mm-hmm.
we shutting off tumor suppressor genes that we want humming along and functioning really, really well?
Mm-hmm.
Are we, or conversely, if we're not adequate, if we don't have enough methylation nutrients in our bodies, are we allowing the expression of genes we don't want expressed? I mean, are we causing our epigenetic, methylation patterns to be off? And I don't, and that wouldn't be, it's so widespread. I mean, it's the genome is methylated at, many, many, many different regions. One could not say, oh, I'm hypermethylated, therefore I've got these headaches. I mean, it's just too broad, where we can methylate and shut down, inflammatory genes, or they can be, you know, uh, or the genes that regulate inflammation. Maybe we've methylated them and they're shut down. And there's just, it's so varied and massive. I mean, in the research, I'm actually doing a research study on it, and I know that we're going to talk about this soon. But we're measuring what they called epigenetic methylation. They call it the methylome, like the genome, but it's the methylome. So it's the methylation marks on the genome,
Mm.
and it's not all of the methylation marks, and there are, and but it's, there are many, and we're looking at 900,000 data points.
Wow.
900,000. Yeah, so one can't say symptoms A, B, and C are associated with epigenetic, methylation imbalance. It's just too massive. It's just too massive.
What diseases are you really excited about extinguishing after like when we fully understand the methylome? Is there, can you say, I think we can stop cancer. I think we can stop diabetes, or, I'm really confident that we'll be able to do X, Y, and Z once we have all this information.
Well, there's a handful of things. Well, first of all, aging itself is a process where we stop methylating as well. Like when we age, homocysteine tends to rise, and we see regions of the genome be undermethylated or hypomethylating. So aging tends to be associated with hypomethylation. But let me throw in a little wrinkle of complexity. You can still have regions of hypermethylation that you don't want. So maybe if you take the weight of the whole genome, you see there's a trend towards less methylation. But if you zero in, you might see, oh, this extremely important tumor suppressor gene is shut down in this person, and that's bad. So on one hand, we want to support healthy methylation in our aging population
Mm-hmm.
unequivocally, but we also want to do it in such a way that, like, the body is able to allow that robust methylation to happen in a balanced way. And there's just so much more we can do. So just to answer your question, areas that I'm extremely interested in looking at, well, my suspicion is, because we're going to have so much research, so many data points at the end of the study, that we'll be asking questions about this data for, years to come. Um, so one area I'm interested in is cancer, for sure. I am interested in cancer. Um, some of the detox genes you mentioned earlier, we know that they can be methylated and turned off. So you don't even have a mutation. There's no genetic mutation. You get your 23andMe, you're clear, your glutathione S transferase genes are humming along, but in certain tumors, we know that glutathione S transferase genes can actually be hypermethylated. So that would be interesting. So some of the abnormal methylation patterns seen in cancer, I'd like to look at in our study and
Mm.
look at baseline where some of these hypermethylated. It doesn't necessarily mean that they have cancer at all, but maybe that this will increase the vulnerability of developing cancer. So at the baseline of our study, we'll look and see if some of these cancer-associated genes, what their methylation pattern is, and after they do our program, at the very end, have we changed it for the better? That's so cancer is definitely one area. But the other piece that I'm super, super interested in looking at is aging. So there's this scientist out of the University of Southern California, Steve Horvath. In fact, at least I think he's out of the university. He might be out of UCLA. But anyway, he's out of a California university, one of the giant ones. Excuse me if I'm wrong in the specific one. It's either it's University of Southern California or UCLA. But anyway, his name is Dr. Steve Horvath, and he's designed this epigenetic clock. So there are over 300 methylation sites on the genome that he looks at that are associated with aging. So a big question for me is, what happens after people do our program? Are we able to change favorably the epigenetic clock? So that's another piece that I'm really excited to look at. And then there are all sorts of methylation patterns associated with stress, associated with depression. We can inherit these in utero from mom and dad, or we can develop these imbalanced patterns in childhood. We can develop them as adults if we go through extremely stressful periods. And, again, in our study, can we look at some of these patterns and see whether our program, which involves it involves dietary changes, it involves meditation, it involves tracking sleep, and it involves exercise. So it's a pretty involved program. Do we see changes to our genetic response to stress, to the proteins that, what's changing the epigenome? So can we actually change the proteins from produced by our genome by altering our epigenome that create a better environment, a better way for us to respond to stress? So that's another piece that we'll look at. I mean, the questions really kind of go on. We can certainly look at inflammatory genes or anti-inflammatory genes. At baseline, are those pro-inflammatory genes really turned on? And then at the end of the study, are we able to inhibit them? And likewise, anti-inflammatory genes. So I was just reading about NRF2, which is a gene that suppresses NF-kappa B, so NRF2 is anti-inflammatory. It suppresses a very pro-inflammatory gene called NF-kappa B. And so NRF2, what's it look like at baseline? And then at the end of the study, is it different? Are we suppressing inflammation at the level of the epigenome? Therefore, will directly be altering genetic expression. We know that sleep quality influences epigenetic expression. We know that diet has a massive influence on epigenetic expression. So going from, a standard American diet and, changing to our program, what does that do? Our program is very rich in methyl nutrients through food. So at the research to date demonstrates that methyl donors in your diet, like loads of leafy greens, maybe some beets, maybe some liver, healthy methyl donors through diet are not only not associated with promoting cancer, but have a protective effect by and large. So we've got this robust methyl donor rich diet, but we also have foods that, you and I will talk about here shortly called methylation adaptogens, which seem to be able to kind of finesse methylation. They're not just methyl donors pushing methylation forward, but they're finessing it at the level of the epigenome and, kind of helping to dial it in a balanced way.
Oh, that's absolutely something we all would want to do, is just bring that back into balance, because I can see what you're saying, how complex it is that we could be hyper stimulating the inflammatory, the pro-inflammatory, the NF kappa B, so this it's causing
Yes.
too much inflammation. But then over here in this little gene expression, maybe the anti-tumor one is like is hypo, and that's like, whoa, that's not good. You got a hypo over here, which is not good because we want that to be up.
Yes.
We got a hyper over here, and that's not good. We want it to be down.
Yes.
And so really,
Yes.
the for those who don't know what adaptogen means, it means coming back into balance. Whether you're high or you're low, it means coming back into the most balanced homeostasis level possible. Is that correct?
Yeah. Yeah, that really is.
For those who, I know we've kind of talked about methylation for the last few minutes, but just to go back and define, for those who are sitting here going, okay, maybe I've heard of MTHFR, but I really don't understand what is
Yep.
methylation.
Well, and this is really moving beyond MTHFR. Like we're really not, I mean, that's a piece of the story, but it's kind of over, it's over to the side. I mean, I honestly think we've been giving our single nucleotide polymorphisms. I mean, it's as exciting as they are, and as um and as much as we'll return to them time and again, I think that we've been a little bit cavalier in interpreting what's going on with them.
Mm,
So I just caution us around thinking a little bit bigger picture and thinking upstream, like dietary interventions. And let's make sure we circle back to the other ways that we can help with healthy epigenetic expression, because it's way beyond just diet or
sure.
supplements. Like, as I said earlier, like getting enough sleep.
Right, right. It's kind of like we just discovered vitamin C. And so everyone's like
Right.
super excited. There's like
Yeah.
15 other vitamins that were just,
Yeah.
aren't getting enough attention.
That's a good analogy. And the complexity is so massive. I mean, sometimes we'll adopt an attitude, well, if a little bit of this is good, then way, way, way more must be so much better. And it turns out that that's probably not the case. In many things in life and many things in functional medicine, it's what we call a U curve. Too little is not good and too much is not good, like the two tops of the U, and you want that sweet spot at the bottom of the U where you're in balance. And I think shifting our thinking to that, to balance, is just so essential.
I love
Um,
it. So what is
yeah,
methylation?
methylation. So methylation is this massive, 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 multifactorial process that happens in the body. But in the most simple way, a methyl group is just a carbon with three hydrogens. If anybody can go back to their high school chemistry class, it's an element of carbon, and there are three hydrogen groups attached to it. It's itty bitty. It's like the smallest player in the body. And we put methyl groups, we can take that little methyl group and stick it onto compounds in the body, and then we can pop it off of compounds. So we're forever putting methyl groups onto things and taking it off of things. And you can think, now, again, this is another interesting sort of illustration of how it's difficult to pin down what symptoms are associated with methylation. It's because it's so fundamental and it's happening all over the place. I mean, to date, there are over 200 enzymes using that methyl group in humans. There's over 200. So methyl groups are just being used all over the place in such a wide variety of reactions. Um, anyway, let me circle back to what you had a basic question. Let me just try to answer this,
Yeah,
because
absolutely.
I get off, and circle me back when
No, I
I
love it.
when I when I scamper away. Um, um, so methylation is about making So S-adenosylmethionine is the compound in the body that we produce that carries that methyl group and that allows those enzymes to use that methyl group and put it onto compounds in the body or take it off of compounds. So a very well-known way that we use this is to make adrenaline in the body. We use this SAMe, this S-adenosylmethionine. So we donate that methyl group to produce adrenaline, but likewise, we actually use that SAM with that methyl group to metabolize adrenaline. We use it to make dopamine, and we use it to metabolize dopamine. We use methyl groups to metabolize our estrogens and to make them safe. And then again, we use the SAMe and a methyl group to get rid of histamine in the body. And, then going over to DNA, of course, we're using methyl group SAMe and that carbon and 3 hydrogens all over the DNA to regulate DNA expression. So it's a far and wide. We make certain fatty acids with methyl groups, and then we transform them further with methyl groups. We could go on and on. It's a fascinating, it's just a fascinating.
Now you've talked about, and we'll definitely get into it, but there are lifestyle changes that are gunking up the works, that are making things not optimal for our methylation. And there's definitely diet that can, stimulate, for example, the pro-inflammatory or suppress the anti-tumor. All the things we want to make sure we have. Diet, like standard American diet, not getting enough sleep, having lots of stress, all that we always knew those were things we shouldn't do. Like everyone knows, eat your greens and drink lots
Yes.
of water and get some
Yep.
exercise. But now we're seeing like on this tiny microscopic level
Yeah, it's
that
no
it's
joke.
like, yeah,
It's
it's,
no
yeah,
joke.
exactly. It's no joke.
They can have really far-reaching effects. And it's not just, oh darn, I didn't sleep well, last night. Actually, it's funny because I was lecturing on this in Ireland and I was horribly jet lagged. And there's research out there. A lot of the research we have in epigenetics right now is limited to animal studies, but there are more and more studies coming out in humans. So we can't do a one-to-one extrapolation, but there's research where they deprive animals of like one night of good sleep. And it's not just the next night, that they're messed up, or the next day. It lasts. I mean, it really lasts. And you can imagine if you always get poor quality sleep, um, the the lasting damage that can happen on the epigenome, which alters genetic expression. And these mice, it influenced how what they call neurogenesis, their growth and maintenance of their, the neurons in their brains. So it has this
Mm.
far-reaching effect. And so it was the irony wasn't lost on me as I lectured, terribly jet lagged, and went through that slide. Um, so yes, the epigenome, it's not just a matter of, oh my gosh, I had a burger yesterday, or a McDonald's burger with, a McDonald's shake or something yesterday, so I'm not going to today. The fact is that it can have, implications that last further than we previously realized. And certainly if you continue to repeat it, it can be scary. I mean, we know that the patterns on our epigenome are heritable. I mean, that's another area that I haven't even touched on here. Not only are we influencing the course of our body over time, but if we're preconception, if we're a man, and men, you're as in this as women, your methylation pattern, your epigenome, which goes beyond methylation, by the way. There's other ways that we augment epigenetic expression. There's other quote unquote marks, as they call them. But methylation is the area that there's just, oodles of research on. And so it's the area that we're focusing on in our research study. But men and women preconception will influence the course of their offspring. They'll inherit the methylation pattern as it is in conception. And then of course, while in utero, while the fetus is developing, that's a extremely vulnerable time to epigenetic influence, massive. So what mom's doing while baby is growing, be it experiencing loads of stress or eating bad foods or being exposed
Mm-hmm.
to toxins, or meditating and living a healthful lifestyle, will influence. There's a really rather incredible body of research out, and it was based on, or it started at what they call the Dutch hunger winter. So during World War II, um, a region of the Netherlands was completely cut off by the Germans from food and supplies of any kind. And so they were starving. And it was this finite period of time where they were starving. Um, Women who were pregnant at that time gave birth to offspring who have had higher risk of diabetes, higher risk of cardiovascular disease, of obesity. Their epigenomes were changed profoundly. So that's not genetic inheritance. That's not the genetic mutation that we talked earlier about with regard to Angelina Jolie. That's an immediate change to genetic expression by changing the epigenome. And then they've been tracking the offspring, the generational offspring of these original Dutch hunger winter people, and they have found over time that there's increased risk of these conditions with generations later.
Mm-hmm.
And so that's another incredibly powerful and really, really important piece of understanding epigenetics, is that, what you do today, actually who you are, is influenced by the generations past, not just your genetic mutations from millennia, but the more recent generations, how my mom lived, how my grandmother lived, how my great grandmother, how my great grandfather lived, the hardships that they went through, the depression I think about. And then when my family migrated from Poland or from Ireland and in England and so forth, like those life influences, those periods of feast or famine, the high stress, I mean, that would augment the epigenetic marks that would be handed down to my family and ultimately to me. So, and it's not, it's not, so there's a continuum of expression. So there are regions that are very lasting. There are epigenetic marks that aren't going to be changed by diet and lifestyle. And then there are regions of the epigenome that are more vulnerable to these changes. So for instance, and if you're a female mammal, you've got two X chromosomes. One of them is methylated and shut down. Now that's not going to change. That's just going to carry through in all your cells in your body. You're going to have one of them shut down. That's a lasting mark. But conversely, there's other regions that can absolutely be influenced by, the various exposures our ancestors experienced. And then, again, in utero, what happens with mom, if she's smoking, that has a profound epigenetic influence on offspring and again, generationally, or what you're doing today, if you're choosing to, make the most healthful choices, you're going to influence the descendants of the cells that are in your body today. Those cells coming forward, the various methylation patterns on them, you'll have an influence what you do today. So it's not short term. It's longer term.
What about 70% of the adult population's on at least one prescription medication, which gives us a bird's eye view of the health of our nation, and many other countries follow suit in terms of that statistic. So technically 70% of
Is
our
that
adult
true?
sorry?
Is that true? Is that true in the great country of Canada? Or is that a U.S. quote, a statistic?
Well,
Are you guys right there with us?
Canada's very similar. It's I would say certain statistics when you look
Yeah,
at it, it's a little bit healthier.
yeah.
Because
I'm with
the
you.
it's similar, but it's a little bit healthier, like life expectancy sometimes, or percentage of disease, like the amount of people that will get cancer now in the United States. It's between 1 in 3 and 1 in 2, depending on whether you're man or woman, are expected to get a cancer diagnosis in this lifetime. And that's
Mm,
ridiculous. That's just like, and then 1 in 3 people have diabetes or are pre-diabetic. So you look at these statistics, and yes, some diseases are going down, but a lot of them are going up. And this is something we really need to pay attention to. if 70% of the adult population is on at least one prescription medication, that means that 70% of the population knows they're sick, right? And
Mhm.
they're going to take a pharmaceutical drug. How much does pharmaceutical drugs affect epigenetics or affect methylation? Does
That's
it
a
gum
really
up the
good question.
works?
Well, it depends. I mean, I would say that you could probably track most things ultimately to being able to augment, healthy epigenetic expression, but it would depend on the medication. It would, and you might have to pull the thread for a while. So, um, some drugs are metabolized using methylation. Methylation is a piece of how we detox things. And so if the medications that you're taking lead to methyl donor drain, if you're spending and wasting your those precious methyl groups, you'll gunk up the works for sure. There are probably drugs that are more directly toxic through other mechanisms. I mean, certainly there are drugs that are oxidative and, may lead to DNA damage. So, I mean, I can't speak to them all as a whole,
Okay.
but some would be worse than others.
Now, when you look at the top 5 drugs sold in the United States, 4 out of 5 of them are directly related to in suppressing the immune system in some way because, or help, supposedly helping to treat autoimmune disease. Are you seeing autoimmune disease as related to? Can you see, like, as you go through this methylome project, that autoimmune disease is created by these epigenetic expressions, or can we? Is there a positive outlook that we'll be able to reverse it when we have a deeper understanding of the methylome?
Well, I would say I would say that yeah, I would say it's a kind of a big question you asked me, but yes, we know that there are quote unquote differential methylation patterns in many autoimmunity conditions. In fact, you can look it up. The research is so prolific right now. It's just there's new studies coming out all of the time looking at methylation patterns in association to disease. And autoimmunity is a big one. Autism, incidentally, is a really big one. Neurodegenerative conditions like Parkinson and Alzheimer, we know that there's imbalanced methylation patterns in those diseases as well. So pretty much any chronic condition you want to put your finger on, you can see that differential methylation patterns, imbalanced methylation patterns appear to have a piece of the puzzle. So going
Wow.
back just a very fundamental mechanism, just off the top of my head, would be, again, is that NF-kappa B, that pro-inflammatory gene, is it turned on or not? Is the regulator of that pro-inflammatory gene NRF2, is that turned on or is it turned off? Certainly in somebody who's got a predisposition to developing autoimmunity, whether those genes are allowed to function or whether they're inhibited is going to play a direct role in the autoimmune process. I mean, there's no doubt about it.
That's fascinating that autism, that you can see it, you can see in
Hmm.
the methylation. I know, like, Dr.
Yeah.
Diedrich Klinghardt, I had him on the show, and he's been helping children with autism for 40 years, and he gets them on, green smoothies, like, getting them eating lots of green vegetables and really cleaning up their diet and lifestyle. And he's had people who were on, or children who were on the spectrum, no longer be on the spectrum. Is that what you're saying? That if we understand and we can help the body have the healthiest and most balanced methylation possible, that someone could reverse autism?
I would say that it's without question it's a piece of the puzzle. So Jill James, who's a great scientist, I believe she's out of the University of Kansas. She's been looking at methylation and autistic spectrum disorders for like her entire career, or bulk of her career. And so she's done studies looking at methylation behavior in kids on the spectrum for a long time. She recently, in the last 5 years, published a study looking at um, the methylome in autistic kids as compared to controls. And she found a pattern of hypomethylation in autistic kids, and also increased DNA damage as compared to controls. And sometimes the controls were siblings, or age matched controls. So epigenetic hypomethylation, global hypomethylation. I would not be surprised, again, though, if you drill down and look a little bit more closely. I bet certain genes are hypermethylated and other genes are hypomethylated. But when you take the weight of the entire genome, the trend is towards less methylation. And so that's what she demonstrated. But previously, she's looked at the methylation cycle. She's looked at the quantity of S-adenosyl methionine. She's looked at the quantity of glutathione, methionine, homocysteine, and she's found imbalances there. So in the ability to make our universal methyl donor, adenylyl methionine, it's imbalanced in kids on the autistic spectrum all the time. It really is. So addressing methylation in kids on the autistic spectrum is essential. There's just no doubt about it. And that is a piece of the puzzle. Now there's more going on, right? We know gut is always a piece of the puzzle, which incidentally, a healthy gut will influence healthy epigenetic expression as well. But, gut's always a piece of the puzzle in kids on the autistic spectrum. As well as diet and, micronutrient insufficiencies, vitamin and mineral deficiencies are also really common in kids on the autistic spectrum. And incidentally, going back to your question with regard to autoimmunity, there's a higher incidence of autism in parents with autoimmune disease, actually, in moms with autoimmunity.
So
There's a higher
if a mother has autoimmunity, that there's a higher incident of having a child with autism.
Yes. And yes, that's right. And when you look at kids on the autistic spectrum, you can often find certain autoimmune antibodies present. So
And if
it's a
the
piece of the puzzle.
mother were to reverse and heal her autoimmune condition and no longer have it, would that then not be less likely to create an autistic child, or are you saying it's baked into the cake?
I would say that it's likely going to help outcome for sure. No doubt about it. Because again, with an active autoimmune process, there's a lot of oxidative stress, there's a lot of inflammation going on. There are imbalances that can be addressed and remedied. So bringing a child into an environment that's in utero, growing a baby in an environment that's more pro-inflammatory and damaging, there are worse outcomes than if you're able to quench and reverse that, no doubt about it. There's no study to my knowledge where they've actually looked at reversing or minimizing autoimmunity in parent and whether or not that reduces the incidence of autism in offspring. I don't think that research has been done. But if you ask clinicians and if you look at anecdotal reports, I'm sure they would argue that this is the way that you need to go. And being a functional medicine doctor in practice and working with men and women pre-conception to optimize their wellness, there's absolutely no doubt that we want to do that to bring baby into the most healthy, in utero environment.
Mm-hmm. What about heavy metals? Let's say heavy metals are built up either through vaccines or through, someone being exposed in their environment, or maybe they were a heavy smoker at one point. They have heavy metals in their body. Does that affect the methylation process?
Yeah, definitely. Yeah, all toxins can influence epigenetic expression.
Got it.
Absolutely.
And that,
So
like
you know, orga-
vaccines, for example, right? So these children are getting 70 doses of vaccines in their childhood. And whereas back when we were kids, there were like 8. It was or some really big difference between what we saw in the 80s and what we're seeing now. Is that amount of heavy metals in vaccines? Do you think that is also a contributor to what we're seeing in these changes?
that's an interesting question. So I don't. There are. I mean, I would just say that that vaccines probably have some influence on the epigenome. Why wouldn't they? And while there's scant mercury, thimerosal, I think, has largely been ushered out of vaccines. Certainly, aluminum is a pretty common adjuvant. And can that influence the methylome or epigenetic expression? Um, I would say that likely. I haven't specifically looked at aluminum and epigenetic expression, but if I did a cursory search on PubMed, I'm sure that it can have some influencing factor. I mean, we know that mercury and lead can, and we know that toxins like BPA or phthalates, parabens, various pesticides, various herbicides, and just the whole body of organotoxins. There's plenty of data out there that they can influence negatively epigenetic expression. So it's there. It's just a matter of asking the questions of the data. And as I said before, research is really pouring out. So if somebody's curious about any of these areas that we're bringing up, I would just encourage you to look at it. I mean, the research can be a little bit complicated to read, but check it out. When I published our methylation diet and lifestyle ebook in when did we publish it? I want it maybe 2013 now. Or maybe it was 2016. I'm so sorry. As you know, I have a newborn baby, and so I'm sure my epigenetic methylation has been augmented in this sleep-deprived process of mine, and so I'm not so good with dates. But when I wrote the preface to the book, I went to PubMed and I typed in the search term epigenetics, and I got at that time almost 90,000 research studies that came up. Almost 90,000.
Wow.
90,000. It's completely insane. And I bet if I went back and typed that search engine into PubMed, of course, for anybody who doesn't know, is the National Institutes of Health database of research, of global research publications. So anything that's quote unquote indexed, it will be linked in PubMed. So you can get a survey of the bulk of the research that's available in the world by going to PubMed. And that's PUBMED. And if you type it into a Google or search engine, it'll bring the link up right away. So if you wanted to go to PubMed and type in epigenetics, I bet at this point in time, there'd be over 100,000, maybe well over.
Amazing.
So these studies are coming out just daily in droves. Everybody is looking at epigenetics. It's just a hot area, and it's really fun. There's a lot of animal studies. There's a lot of cell studies. There are some human studies, and there are more and more human studies coming, but it's a new area and there's much excitement around it. And of course, we're looking at how you can augment epigenetic expression. A lot of the research out there now is looking at different disease states, and of course they're interested in drugs that augment epigenetic expression, but we're in there contributing, looking at functional medicine principles to augment expression.
Absolutely. Now you've seen that through eating foods that we can healthfully balance the
Yes.
methylation processes in the body.
Yes.
Let's talk about those adaptogenic foods.
Yeah. So again, I want to reiterate that we want to eat methyl donors. We want to get folate. We want sources of B12 in our diet. We want beets with betaine. We want all of our minerals. We just need a good, rich body of methylation donors to keep that happening. But then there's this whole class of what we've termed methylation adaptogens. Actually, a friend of mine, Dr. Michael Stone, who's a IFM faculty as well, and he's a functional medicine doctor out in Ashland, Oregon. He and I were talking one day, and he said methylation adaptogens when I was describing to him the properties of these foods. So he coined the term. I got to credit him on it. But these are compounds that they're in fruits and veggies. They're polyphenols. They're active constituents that augment methylation behavior, DNA methylation. And so some of my favorites, we have a methylation adaptogen handout. People who want to incorporate these into the diet, or if they've already incorporated, turn the volume up on them, can definitely get our download. My favorites include EGCG and green tea. EGCG is really, really cool. Probably the anti-cancer properties of EGCG have in good part, are sourced to its ability to modulate epigenetic expression. Quercetin, so that flavonoid we think about in allergies actually has an ability to modulate epigenetic expression. So it's another one that I absolutely love and use, and I prescribe to my patients all the time. Rosemary, so the wonderful, wonderful spice herb rosemary is a really important, powerful epigenetic modulator. I use rosemary as much as I possibly can in my foods without getting too sick of it, but I've got rosemary powder at home and rosemary essential oils. In fact, I just got a rosemary mist facial toner from some samples I got the other day, and it's so lovely. Curcumin. So again, thinking about all of the research on turmeric powder and its potent anti-cancer, anti-inflammatory properties, no doubt a good portion of that is sourced to its ability to modulate epigenetic expression. Lutein, luteolin, present in or lycopene, a player in tomatoes, genistein in soy. Really, really compelling research on genistein from soy in promoting both a balanced methylation by augmenting hyper and hypo. There is an amazing scientist, Randy Girdle, who's published quite a few very well-referenced studies looking at augmenting methylation expression in mice. They're so interesting. They're called agouti mice, and when he fed them a methyl donor deficient diet, he fed the pregnant mice a methyl donor deficient diet, they gave birth to offspring that were obese, vulnerable to diabetes and heart disease, and had blonde fur, profoundly enough. So these are the agouti mice, and that's because the methyl donor deficient diet allowed the expression of these negative genes that resulted in, or it was just the agouti gene. And when that agouti gene is not methylated, these mice are really heavy and they've got blonde hair, so you can visually see the influence of the lack of methylation. And then they were, obese and had heart disease and diabetes. So, and then conversely, when he fed the mice genistein, or when he fed the mice a methyl donor rich diet, they were normal looking little skinny brown mice without the increased risk for heart disease and diabetes and so forth. So genistein actually corrected the methyl donor imbalance in these mice.
Fascinating.
Incidentally, he caused the same imbalance by giving BPA. So by introducing this BPA toxin into the pregnant mice, the offspring were damaged in that same way. So they were obese and they had these sort of blonde orange coats, and they were, higher risk of diabetes and heart disease. So again, that was clearly showing that BPA changed epigenetic
Right.
methylation.
I heard of that study, and the amount of BPA they gave the mice was equivalent to the amount that we are exposed to as, adult Americans, for example, touching receipts and drinking out of plastic bottles. And it wasn't like they gave the mice huge doses. They kind of gave
Yeah.
them doses in accordance with what we're exposed to on a daily basis. Would you say that we really need to be diligent in avoiding plastics, avoiding drinking out of
Yeah,
plastic bottles,
absolutely.
because it
Yeah,
can
for sure.
change our genetic expressions?
Yeah, I would say for sure we want to. Now, remember that those are in key fetal developmental windows. So they were introducing the toxin into these pregnant mice during these fetal developmental periods where the epigenome is extremely vulnerable. So we all want to be careful, and there are plenty of data demonstrating the toxicity of BPA and other organotoxins, and they definitely demonstrate that they can negatively alter epigenetic expression, but especially in pregnancy.
I heard in that study that the that expression of the would actually last for several generations. That there wasn't just affecting the mice that were born, but that their offspring also it remained. Is that correct?
Um, it continues to be heritable.
Until we eat the foods that can reverse it, or is it baked into the cake?
So that's a really awesome question, Ashley. And I think the answer is pretty nuanced. Like we need to do the best we can. And there's a continuum there's a continuum of expression of the epigenome. So when we started this conversation, I alluded to that. Some things are baked in the cake, as you say, and some are more nuanced. And as cells turn over, and new methylation marks are put onto the genome. Those are windows. So there are windows during cell turnover and other times where we can favorably augment epigenetic expression. So I would say not all is lost, but it is a continuum. So some epigenetic marks are going to be really resilient and maintain, and other epigenetic marks are more labile to environmental influence, either negative or favorable. So the take home is that we need to get in there and do the best we can with changing it in real time, either whether we're post conception, like I'm not going to be having a baby anytime soon, but we can look at all the cells in my body, all these new cells that are being born every day. My choices now are going to influence their expression, and then the daughter cell of that cell and on down the line. So we're reproducing in our bodies all the time with cellular regeneration. And so at any moment in time, we can enter into that conversation and optimize it. But some things are going to be more responsive. Some, regions are more responsive, and some regions are less responsive.
What lifestyle? So we've talked about avoiding plastic and making sure that we're getting adequate sleep. What other
Yeah.
lifestyle, either done daily or weekly or monthly, can we do that have a positive influence? I heard that using a sauna from a doctor that also is really into helping the body with methylation. That he says that some methyl groups are improved when we detoxify using a sauna. Have you seen that, or are there other lifestyle changes that we should implement?
Um, Honestly, I have not looked at the epigenetic changes with regard to sauna. I mean, the fact of the matter is, we can assume something's probably happening, but I'm not aware of anybody who's researched. Let's look at your epigenome baseline and then have you sauna for a while and then look at follow up. I mean, we can't measure epigenetic assessment is only available, but for the most part in the research setting. Like it's not something I can bring in my practice yet. I think eventually we will be able to. I'm sure we will, but right now it's outside of the realm. So one might be able to suspect that sauna is going to influence it, but I don't know that we can quite prove it yet. So things that we want to do and what we've demonstrated. So we know methyl donors in the diet. We know a methyl donor rich diet, as I've outlined before, is going to favorably influence methylation. We know that using these methylation adaptogens that I just talked about can favorably influence methylation. And this is based on research, not there's not a heck of a lot out there in humans. Some of them are cell studies, some of them are animal studies, but that's what we know now. And that's another reason why we're doing our research study, so that we can contribute to this body of knowledge in humans, like our study is being done in humans. So we know diet is a major player. We know that sleep influences epigenetic expression in rodents. What else? We know that exercise. So there's actually quite a bit of research, relatively speaking, on exercise and epigenetic changes in humans. There's quite a bit. And so balance exercise. If you're a couch potato, jumping up and doing CrossFit immediately is probably not going to lend itself to favorable epigenetic expression. But if you kind of meet your body where it's at, and slowly increase, the research suggests that a more balanced approach is likely favorable to good epigenetic expression. Tai Chi was shown to be really, really helpful in a study looking at middle-aged women. In fact, one study looked at housework and epigenetic expression. Not that any of us are really excited to go home and do that. Housework. Housework is a form of exercise. I mean, what a terrible study design. It's just so funny to me. But, that was shown to be favorable because it's movement. You're up off your feet, you're moving around, you're doing stuff. You might be hustling if you've got a lot to clean. And then good gut health. So we know that the microbiome has a major influence on not just making methyl donors. So for instance, we can make B12 in the gut, we can make B6, we make folate, we make a whole lot of nutrients associated with healthy methylation expression. But we also the gut bugs themselves, balanced or not, are going to influence how our epigenome is expressed. So a good, healthy gut is important. And then, as you alluded to, well, a few times we've touched on minimizing our toxin exposures, minimizing, of course, all the toxins in plastics and lotions and makeup and, just the myriad things, and pollution, plus minimizing our metallotoxins like lead or mercury in fish, etc. All of those things have been shown to negatively influence epigenetic expression.
In your practice and all the, in your clinical experience, what are 2 or 3 actionable steps people can take to strengthen and heal and help their gut biome so that they can help the methylation in their whole
Well,
body?
I would say you could get a good bang for your buck by using methylation adaptogens every day.
Hmm.
Blueberries are pretty fabulous. And I eat, especially now while they're, well, mostly now while they're in season and they're so heavenly and, fresh and yummy. I have blueberries most days. As I said before, rosemary. I use curcumin or turmeric in cooking, and I also take curcumin capsules. Um, I would think about that. Think about starting. I use a little bit of soy in my diet, not a ton, but genistein is a pretty important player. So think about methylation adaptogens. I just love the idea of relying on body wisdom to make some of these decision points on whether something is methylated or not, whether my epigenome, whether a particular gene is methylated or not. So methylation adaptogens, think about those. And then the other piece is to make sure you're getting methyl donor rich nutrients in your diet. And, foods is all, they're all prebiotics. They're going to, introducing high fiber, nutrient dense foods into your microbiome, this is circling back to your question, will favorably influence who's produced there and how they influence the epigenetic expression. So I think, just introducing some of those really potent foods in the diet are great. And then there's there are some probiotics that appear to be able to promote folate production. So getting on a good probiotic protocol isn't a bad idea. I mean, I favor a food first approach, but
Would you say a variety of fermented foods is better over taking like in a capsule, taking a probiotic in a capsule?
I think taking a food first approach is a good idea. In our study, we are using a probiotic, and we are actually using, in fact, we're selling the probiotic on our website if people are interested, but we're using Lactobacillus plantarum strain in our study, which may be able to increase folate production. Um, and help just favorably augment the methylome. So what I would say is, yep, food first for sure, and a probiotic. In fact, I take this probiotic every day. I think it's a good idea. I think it's an additional important support. The other thing we're using in our study, so we're using 2 supplements. We're not using B12 and B6 and all of that. We're using a probiotic, and then we're using what we're calling a methylation adaptogen product, and that's a organic fruit and veg concentrate. So it's just full of those rich methylation adaptogens that I've talked to you about. So we're having our study participants take that twice a day as well.
Excellent. And we're going to have the link to everything that we talked about today, your website, and where they can purchase those if they choose to, and check
Yep.
out your free ebook. That's all going to be in the show notes of today's podcast at learntruehealth.com. Your website is drkarafitzgerald.com. And what's the name of that supplement, the probiotic?
It's called MDL Flora.
Okay, got it. So yeah, so there's on your website there's a link to the store, and then they can go check that out. And then the MDL Adapt, is that the
Yep.
that's the powder that you talked about?
Yep. That's a quick hit of methylation adaptogens. You can do that a couple of times a day and just bang that out. Or even if you just do it once a day, you can, get your hit of methylation adaptogens, and it tastes really good too. The other thing that we're selling, because we think it supports healthy epigenetic expression, is a concentrated medium chain triglyceride, concentrated for chain lengths 8 and 10. And I think we didn't spend too much time discussing fats here, but another important piece of the puzzle for us are good fatty acids, and medium chain triglycerides are helpful for myriad reasons. And one of the things they can promote in the context of a healthy diet, medium chain triglycerides, as your listeners probably know, can help to make ketone bodies. A lot of people are doing ketogenic diets. You perhaps have a podcast on it, but we know that ketone bodies are actually really pretty potently anti-inflammatory in and of themselves. And there are epigenetic modulating properties here as well. And so we include medium chain triglycerides in one of the things that we're recommending for a good methylation diet and lifestyle program. In our research study, we are not using the MCT oil, but we are using, we're recommending coconut oil.
Excellent. Very interesting. And you said it was your MCT oil is 8 and 10, and that's the absolute highest quality. Most of those ones that are sold in the stores are 6 or 6 and 8. And those are the much lower quality. There's because people go, oh well, I could buy a bottle for $20. Yeah, but what you're buying is like this really, you're buying the sludge. You're not buying the high quality MCT oils. So there's a big difference in the quality, and in what it'll do for you. Well, we'll make sure the link to your store is in the show notes of the podcast. Thank you so much for coming on the show. And then how can they get your free book? Where is that on your website?
Our methylation adaptogen. Well, we can get a link to you, but if you go to Dr. Kara Fitzgerald, DRKARA Fitzgerald.com, if you just go to my homepage, and you'll see links to the methylation diet and lifestyle. Right there.
I see. It's underneath the photo. Yes, underneath the photo, because there's it says for professionals or for customers, and then you go below. Now, for professionals, we have a lot of holistic health professionals that listen to the show, and do you offer any trainings for them?
Yeah, we do. God, thanks for asking me, Ashley. Actually, so the methylation diet and lifestyle ebook is geared towards professionals. Savvy regular people will enjoy it. And, if you go to our site, you'll find loads of blogs. There's just a lot of content there. In fact, the link to our study is on the methylation diet and lifestyle page. So you can find that also if you click on one of those boxes, or if we give you a link. So you can actually go to clinic. It's clinicaltrials.gov, which houses the outline of our study. So people can find that on our page, and professionals might be interested in that. Professionals can find our book. We've lectured all over the place. Actually, I was in South Africa late last year, and that day-long training that I offered in South Africa, we will be making available as a downloadable recording, or
Ooh.
series of recordings, because it's a day-long training. It's pretty involved. So me and my co-author and colleague Romilly Hodges will be recording that content and making it available soon. You can buy our Cleveland Clinic lectures. So we've presented, we have a series of 2 webinars that we delivered to the functional medicine center over at Cleveland Clinic, and those are available on our website.
Excellent. And there's also, you have a podcast. There's a link to your podcast, and you have wonderful interviews. So I know my listeners would love to check that out.
There's actually an interview with Randy Girdle, the whole agouti mice studies that we were
Nice.
talking about. Yep, he's in there. Incidentally, that first paper they published is the most cited study in the history of science. A little interesting factoid.
Really?
The history of science.
Oh my gosh.
That's how influential it was, his epigenetic research.
Wow. I know. I mean, I've heard of it, and I've even mentioned it in past episodes, because something as simple as drinking out of a plastic bottle, especially now that we know, especially when pregnant, can have detrimental effects. I mean, these plastic bottles need to come with warning labels. We need to really just consider banning plastic bottles altogether. Now they've got water. If you want to buy water in the store, they've got the boxed water. It's like a almost like a milk box. So you can just buy a liter of water in a box, and that would be better than buying a plastic bottle. But just that alone, like we have to.
Yeah, that's right. Just try to carry your own in a glass bottle.
Carry your own would be better. For sure.
Anyway, Ashley, it was fun to chat with you today, and I hope people get something out of this, and they can certainly find out. We can put an email up there so people can access me if they have any questions, and just loads of content over at the site. And thanks everybody for your interest.
Absolutely. Thank you so much for coming on the show.
You're welcome.
Do you feel like you're missing something? Are you searching for the right answers to solve your health issues? Do you feel like you should have more energy and mental clarity? With everything you're doing for your health, you may be missing one key component. Our body needs 90 essential nutrients every day to function optimally. 60 minerals, 12 amino acids, 2 fatty acids, and 16 vitamins each and every day. Because of the farming practices over the last 100 years, most of our food has 60% fewer vitamins and minerals compared to just 50 years ago. So if you aren't eating 8 cups of a variety of fruits and vegetables each day, you may be missing some of your essential nutrients. These are the raw building blocks the body needs to create new healthy tissue, healthy hormones, balanced digestive system, strong muscles, bones and joints, and maintain an optimal functioning nervous system. Especially if you're experiencing more stress, or if you've gone through an illness like an infection, that takes more resources. So if you're not consuming more vitamin C and more of all the 16 vitamins and all the 60 minerals when you're going through more stress, either physical stress, emotional stress, mental stress, those stressors take more nutrients to kind of survive those bumps in the road in life. And over time, that whittles away, that kind of depletes our nutrient tanks, our stores in our body. Without these 90 essential nutrients, things start to break down. Now, you've experienced these breakdowns. Maybe you get migraines. Maybe you're exhausted. Maybe your hormones are out of balance, your digestion's out of balance, or you have some aches and pains. Maybe you've even been diagnosed with something. You have a series of symptoms, and if those symptoms all look like something, then we can diagnose it, right? That's what MDs can do. MDs will treat these breakdowns with drugs and mask your symptoms. But if your body has a nutrient deficiency, no amount of drugs will fix the problem. 7 years ago, I embarked on a journey to cure my diabetes, infertility, PCOS, high blood pressure, and chronic adrenal fatigue. I felt like I was a mess. Through my research, I found a company that made natural supplements to address these nutrient needs. They formulated their supplements to exceed all standards of quality. Their minerals are the most bioavailable and absorbed by the body that I have ever found. After getting on their protocols for healthy hormones and blood sugar, along with their dietary recommendations for better health, I reversed my type 2 diabetes, I reversed my infertility, I no longer had high blood pressure, my energy and vitality came back, and after 6 years of trying to get pregnant with my husband before we found these supplements, once we got on these supplements, we were able to conceive our wonderful healthy son, who's now 3 years old, and he is amazing, and we would have never had that had we not found this company. Speaking of our son, he's also taking these supplements for optimal health. His pediatrician thinks they are amazing. If you'd like to give these supplements a try and see for yourself if you're experiencing a nutrient deficiency, please go to takeyoursupplements.com. That's takeyoursupplements.com. Their health coaches are phenomenal. I personally know all of them. They're amazing people. And I just want you to know, as my listener, I feel like I need to protect my listeners. I would never promote anything that I didn't 100% believe in and I didn't feel was healthy or good for you. I feel like you're my tribe, and I'm sharing this information. In fact, for the last 2 years, the only reason why I've been doing this podcast is so that I can help as many people as possible gain their health back. And so the health coaches at takeyoursupplements.com, I really trust that they will make sure that you're well taken care of. They will work with you to help determine the best protocol for your nutrient needs and work within your budget. They will also help to implement a holistic protocol that includes supporting a healthy diet and lifestyle. Go to takeyoursupplements.com, fill out the form, and one of their health coaches will get back to you really shortly. And then you guys can schedule a time to talk on the phone, and they will work with you to help you dial in all your nutrient needs. I really look forward to hearing about your experience with them. Please feel free to reach out to me. You can reach out to me in our Facebook group. Go to Facebook, search Learn True Health, and join our group. Let me know what you think about the wonderful health coaches at takeyoursupplements.com. And by the way, when you go to takeyoursupplements.com and you get assigned to a health coach, they're your health coach. You're not going to keep getting a different person every time. You get one person, and they work with you and they hold your hand for months down the road. They're there for you to support you month after month while you're on your nutrient protocol, and they're helping you dial in your nutrient needs. They're really wonderful like that. So I know you'll enjoy your experience with them, and I'd love to hear about your experience with them. Please feel free to, you can email me as well, ashley@learntruehealth.com. I love hearing success stories. Like I said, I've been working with a supplement company for my own health for the last 7 years, and I've reversed so many issues. I love sharing this information because I think that many of you will be able to resolve your issues with nutrition, just like I've seen many people do. With that said, go to takeyoursupplements.com, fill out your information, and a health coach is very excited to start working with you and helping you get your health back.